Good afternoon, students. Or I guess depending on when you watch the video, it'll be morning, but this is what a virtual lesson is going to look like. We are going to go over lesson 1.3 notes step by step on how to accomplish not only the problems, but the different examples that you are going to see in your test coming up on Friday. So this is lesson 1.3, modeling with linear functions. This is going to be the learning target. This is exactly what not only you see in the book, but what we see in the notes as well. I always include this slide, which you can also find in the classroom underneath Algebra 2. So we're going to start off with the key idea. If you did not get this key idea down, please go ahead and pause this video, write this down, because we will need to know slope-intercept form, point-slope form, and then how to find one of these formulas based off of just 2 points. So go ahead, pause the video while we look at our first example. So with this first example, it says writing a linear equation from a graph. Now, what's really nice about a graph is that you are given a visual, and so you can use that visual to kind of help us out. It says the graph shows the distance asteroid 2019 GC6 travels in X seconds. Write an equation of the line and interpret the slope. The asteroid came within 136,000 miles of Earth in April 2019. About how long does it take the asteroid to travel that distance? So looking at this graph, the very first thing that I would probably do is recognize that this line not only goes through the point 6, 21, which we're told, but it also goes through that origin point of 0, 0. So, I can't write on this. All right, that's a little bit better, so that way I can write on this as well. But looking at this, I would recognize that we also have this point 0, 0 along with that point 6, 21. So whenever it says write an equation of the line and interpret the slope, first of all, I need to deal with a line that has the slope. So with that, I recommend trying to do y equals mx plus b form whenever you can, or that is your slope-intercept form, where m is the slope of a line and b is your y-intercept, or where that line crosses or intersects the y-axis. Very first thing, find your slope. Your slope will be rise over run, which that general formula is this. And from there, this one's kind of nice because we can use our origin point 0, 0 to help us out. So I would use... Sorry, my dog's crying. I don't know what's going on. Give me 2 seconds. So I would use the point up here as my second point, x2, y2, and my origin as x1, y1. Something very nice that happens is whenever you do this math, it's just 21 over 0, 21 minus 0 over 6 minus 0, which is 21 over 6, or simplified down to 3.5. I like to leave my slope as 21 over 6. I like to leave it as a fraction, but for the sake of this example, they do have it simplified down to 3.5. So we would just plug that in. Y equals 3.5x plus b. Now we still have to find b, which we're just going to use the graph to help us out with. Notice that this line intercepts the y-axis at 0, 0. Where it intersects, you can really just take your y-coordinate, and that is your b. So for this, it's just going to be y equals 3.5x plus 0. Well, I don't have to write that 0, so y equals 3.5x. That is writing the equation. We are 100% done with that part. Now we have to interpret the slope. So this slope, this 3.5, one way to kind of think about it too it's 21 miles over 6 seconds. Now, where am I coming up with these units? If you were to look at the graph, we have distance as your y-axis label and seconds for your x-axis label. Your rise over run will always be y over your x. If y is in miles, then the top number will be in miles. Since x is in seconds, your bottom number is going to be in seconds. So even though it simplifies down to 3.5, this represents that every 6 seconds, the asteroid's going 21 miles. Looking at this one, that 3.5, this is just a 3.5 over a 1. So same ordeal, we can say for the slope, for that interpretation, the asteroid goes 3.5 miles every 1 second, which is pretty dang fast for pretty much anything. That's really fast. I would not want to mess with that asteroid. That is for sure. All right, so that's part 1 of this actual example. The next part says the asteroid came within 136,000 miles of Earth in April 2019. About how long does it take the asteroid to travel that distance? Okay, notice this is 136,000 miles. Miles is distance, meaning this number is a y coordinate, equals y. In order to find out how long does it take the asteroid to travel that distance, all we would need to do is plug that number in for y. We're given a y coordinate, and we need to find what x is. So plugging that in, we get 136,000 equals 3.5x, and we solve for the variable. To get rid, or to get x by itself, it's 3.5 times an x. You will need to divide. The opposite of multiplication will be division. So divide that 3.5 on both sides, giving you just that x value. From there, I do recommend using your calculator for the sake of me just having the notes already. This is going to simplify down to 38,857 seconds. Now, I'm saying seconds as well because of the fact that the time is in seconds. We don't change this unit all of a sudden. We keep it as is. We keep it the same units until we're told otherwise. With this example, it doesn't tell us to do anything fancy with it. It doesn't say to transfer it over to hours. In the example notes, it did that. So I do recommend to just study your basic conversions of things, like know how many seconds are in a minute, know how many minutes are in an hour, know how many days are in a standard month, so on and so forth. Just basic conversion. So if it asks you to do something fancy, you know how to complete that process. For this one, although the book transfers it over to hours, I see no problem just leaving it like this. We don't typically say something's going to happen in 38,000 seconds, but it didn't say to convert otherwise. So just keep in mind, conversions are nifty and good to know, but for this one, I'm not too stressed out about it. That does bring us to part 2, though. It says the graph shows the remaining balance y on a car loan after making X monthly payments. So without even looking at the graph, we have a good chunk of information. We have that my balance for my y is in thousands of dollars, where my x coordinate deals with my payments. So even though this point here is 0,18, that just means that you have 0 payments and you owe $18,000. So 0 payments and you owe $18,000. And just $18K because I didn't want to write the 3 zeros. Part A says write an equation of the line and interpret the slope and y-intercept. So start off with the first part, part A, y equals mx plus b. I don't care what you solve for first. I'm going to go ahead and solve for slope just because I think it's the easiest. Slope is y2 minus y1 over x2 minus x1. In solving for this, I'm just going to use the 2 points that I'm given. I'll use this one as my x1, y1, this one as my x2, y2. So plugging in those points, I have 15 minus 18 over 10 minus 0, which this checks out because that'll be a negative 3 over 10. We do indeed have a downhill slope going on, so that negative is needed. And not only that, but this would be every thousands of dollars. So we would interpret that as minus $3,000 every 10 payments. So I like to keep my slopes as fractions, if I'm being very honest. If I had to take a bet, I would think, or they did, I have the key right in front of me. They went ahead and turned it over into a decimal. I don't like that unless you have to have what's called a unit price or something along those lines. A unit, like a singular unit. I would have to look up the definition, but it comes from geometry. And I mean, we talked about it a little bit in 8th or 7th grade too. But that's just where your denominator is a 1. For the sake of me being the teacher and being able to do what I want to do, we're going to just keep it as a fraction. This is a completely acceptable answer. This just states that it's going down $3,000 every time you make 10 payments, which is just $300 per payment. This y-intercept, I'm going to go ahead and erase that b because we're going to get that y-intercept straight from the line. It is where the line crosses the y-axis, and this y-axis is just right there. It crosses it at the point 0, 18, meaning your y-intercept is simply that 18 value. It is just that value of 18. There's nothing fancy about it. It is where it crosses the y-axis, and you take that y point. You take that y coordinate. Interpreting this, I'm okay if you do something like this for the interpretation of slope. This really does mean that you're going down $3,000 every time you make 10 payments. If you want to make an additional note saying that slope, or for your interpretation of slope, you pay $300 per month on the loan, then that's fine. It's the same thing as this, except you're just stating it a different way. Rather than 10 payments, you broke it down to just one payment. I'm not even going to say per month because it's just per payment. Per payment. Now your y-intercept, what does this 18 actually mean? It just means you owe $18,000. It's your starting point. Where does it cross that y-axis? Well, it crosses it at 0, 18, which means you've made 0 payment and owe $18,000. And that is all of part A. Part B says interpret the meaning of the x-intercept in this situation. So the x-intercept is the opposite of your y-intercept. It means that you're going to go to where this line crosses this x, which is at this point, 60, 0, and just interpret what this means. Now, one way to look at this, 60, 0, keep in mind your x value here is the amount of payments. And I'm told that because of the x-axis, where the 0 here is the balance of that loan in thousands. So what this means for your x-intercept is that you will have paid your loan completely off in 60 payments. You will have paid all the loan off in 60 payments. And that's because your balance is going to be 0 and your payments will be 60. I also just realized too that I didn't answer all of part A. So I'm going to do that real quick, like part A, part 2. I'm pretty sure I discussed this in all my classes, but just for notes-taking purposes, that 36 payments is the number of payments, which is your x. So this will mean x is equal to 36, which you just plug into your equation. So what happens here, and I'll even show my work over to the side. We have y equals -3 over 10 times 36 plus 18. Showing my work, you'd have y equals a negative 10.8 plus 18, which means y is a positive 7.2. Due to the fact that it is in thousands, this is 7.2 thousand, meaning that it turns into $7,200. I'm so sorry that I did end up missing that one particular section. I got sinus brain going on, so I did want to make sure we go back. This is also part of A, asking about what is the remaining balance after the 36 payments. And then B is just explaining what that x-intercept is. All right, so now what happens with C? It says, what happens to the equation you wrote in part A when the y-intercept remains the same and the x-intercept changes to 72? What changed in the problem? So if we were to look at this, right now we have the balance ending after 60 months. But what happens if it goes ahead and extends this line over to 72? Well, just looking at this graph, we're going to have a line now that looks like this. It becomes a little bit flatter overall. So our slope becomes flatter. And I'm going to show you what that means mathematically. Or our line becomes flatter. And I'm even going to change that word from slope to line, because really our line is becoming flatter overall. We are fully extending it out to where we have to pay on it for a longer amount of time, which is really not super ideal. Is it the end of the world? No, but we might just have to pay more interest over time. Now, how can we find this out mathematically? So our first point is that 0, 18, and I'm going to write this out over here, 0, 18. And then our last point would then be 72, 0. So rather than that, rather than the is 60, rather than paying it in 60 payments, we're now paying it in 72 payments. So that's where that 72 is coming from, and then we would owe $0. We could actually mathematically compute the slope by having this as our first point and this as our second point. So what this means now is that our slope is going to equal still rise over run. So 0 minus 18 over 72 minus 0. This still is going to give us a negative slope. But if you were to plug this into the calculator, 18 over 7, or really negative 18 over a positive 72, that is going to equal a negative 0.25 or negative 1/4. So if anything, it's going to take this longer of a time to where the monthly payments have increased, but the amount that I'm going to pay is going to decrease. So now I'm paying around $1,000 every 4 months rather than this $3,000 every 10 months. So our line becomes flatter. We pay less for longer time. Something along those lines. Now, to be personally honest, I would not want to have to pay more over that period of time. I want to get it done as much as humanly possible and as soon as humanly possible. Simply because, I mean, that really does get expensive over a long period of time. So just keep that in mind. And honestly, too, we don't even want to get into interest. Interest is a whole new ball game. So going on to example number 2, it says comparing linear equations. Now, this is physically comparing two lines, or two different types of equations, which we can make into two lines. So it says 2 prom venues charge a rental fee plus a fee per student. The table shows the cost in dollars for different numbers of students at Lakeside Inn. The total cost Y in dollars for X students at Sunview Resort is represented in the equation. So 2 very important things. Lakeside Inn is going to be our chart over to the left, where Sunview Resort is the physical equation. It says which venue charges a greater rental fee and how many students must attend for the cost to be exactly the same. So we need to try to think of how each of the problem comes about. So at this current moment, we know something about Sunview Resort. We know that if nothing else, the rental fee alone is going to be $600. Now, why do I know that for Sunview? Because that's what my y-intercept is. That's $600 or 600 represents the initial fee. So that's not super great. But the issue with Lakeside is that we're only given number of students and the total cost. So understanding that problem, we're given the cost of 2 different venues. We need to compare the costs. So to make a plan, definitely write an equation for the Lakeside Inn as well. Now, I would also represent it as the same way as you did the Sunview, or the same way they gave you the Sunview. Do the y equals mx plus b. Because that way it's going to be a heck of a lot easier to determine the cost and to compare them both. Then compare the y-intercepts to determine which venue causes the greater rental fee. Equate the cost expressions and solve to determine the number of students for which the total costs are equal. That's really after we set up the equation, and then after that, solve and check. The table shows a constant rate of change. Find the slope using any 2 points. These 2 points are coming straight from the Lakeside Inn. So they are setting up that y equals mx plus b in order to help us find that comparison. So they find the slope using the standard formula. They set that equal to 1,800 minus 1,500. They are just taking the 2 points from the chart. And I wish that I was able to write on my Google Notes. And I'm very sorry that I'm not able to. I wonder if I can finagle this. No, I can't. Okay. So with that, they take that 1,800 minus 1,500. That is from 2 of the points. They just used the first 2 points from the Lakeside Inn, where the number of students was 100 and the total cost was 1,500. They also took the number of students was 125, so the total cost would be 1,800. Those we can label as X and Y values. X being the 100 and 125, Y being 15 and the 1,800. Setting that up, they get a slope of just being 12. Now, that's great because now we can use that slope, either point slope form in order to solve for your y-intercept. Now, give me 2 seconds. I really want to try something out here to see if I get the same thing as the book. All right, so what I really wanted to try is to just solve for b. So the way that we learned in algebra was a little bit simpler than this point slope form. They have point slope. If you look at the book at example number 2 on page 23, it totally sets it up correctly. I'm not going to diss the book at all. But what we've looked at the past allows us to say, okay, this is my x, this is my y. Let me just plug it into my y equals mx plus b equation and then solve. So y equals 1,500, great. My slope is still a 12, and my x would be 100 plus b. Using this, we should be able to just solve for b and then re-plug that in. So once again, I'm going to just try it out, which means 1,500 will stay the same, equals 12 times 1. Oh, now it's trying to, no. 12 times 100 is 1,200. Plus AB. Now, once again, the reason I'm doing it like this is because this was actually the way that I at least taught my kids in geometry. And it's also how I taught my kids in 7th grade. So point slope form, totally there. Whenever you need to use it, use your point slope form. But you can use other methods as well, and I like to. I like to kind of cheat the system whenever I can, to be honest, and use material that I've already know that I have taught before, and this is the way I taught. So now get b by itself. We're going to be subtracting a 1,200 on both sides. Now, the reason we're doing this is because it's 1,200 plus b. The opposite of addition is going to be that subtraction, which is going to be 300 equals b. Sweet. I love whenever I get the exact same thing as the book. So after you get that, keep in mind slope is still 12. That doesn't change. Your b is 300. Therefore, your equation for that line will be y equals 12x plus 300. Where that is your slope, that 12 is your slope, and that 300 is going to be basically your initial price. So we've done all this work. What exactly does that mean? Well, we can now compare both of our equations. So I love whenever I get the same thing as the book, just doing it a different way. So with this, they use point slope form, which is completely fine. They have the slope, they have a point, they plug it in and then solve. Keep in mind it's y minus 1,500 equals 12, which is still the slope, times x minus 100. Now, what might mess you up here is that you have to use the distributive property correctly. You have to distribute the 12 to the x and the negative 100, which is fine, and then you add the 1,500 to both sides. You still get the same exact equation, I did it a different way. You're still going to be comparing the y-intercepts. So what my equation and the SunView equation states is that we have 10x plus 600 equals 12x plus 300. Good news is that the initial price is lower on the lakeside. That lakeside is $300 to start off. Your initial price is your y-intercept. But as we go along, we have to, that X represents the amount of students it would take for them to cost equally, 150 students. So I would still probably go with, how many students would, it doesn't even ask which venue would you prefer. So hear me out. I would probably pick the SunView Resort because even though you have a $600 initial fee, which is a lot of money, once you hit 150 students, it's actually cheaper in the long run to go to Sunview than it would Lakeside, which I think is kind of interesting. Like the total costs are the same at 150. Oh, it didn't show me the graph. Boo. So I did switch it back to this slide for just a second because I want to make sure that we have both of these equations down. That 10x plus 600 is representing your Sunview Resort. That is this resort price to where that is your initial cost. And then from there, you will add $10 per student. X represents the number of students that are showing up to this, prom. Now, the other equation, this 12x plus 300, is your Lakeside. So even though it is less expensive as an initial fee, it's still going to be $12 per person. Now, why this 150 is so important is because if you have a school that has over 500 people, you're going to want to go with the cost that is less per student. Because even though the initial fee is higher, the cost per kid will not be as much. So maybe you can not charge the students as much for those tickets. So, and I wanted to show this because it does kind of tag into this third place, this Maple Ridge. So Maple Ridge charges a rental fee plus a $10 fee per student. So not great. The total cost is $1,900 for 140 students. Describe the number of students that must attend for the total cost at Maple Ridge to be less than the total amount at the other two venues. Use a graph to justify your answer. So with this, you need to recognize that this rental fee is going to be our B, and this 10 per student, this is our slope. That slope is $10 per person. Unit rate. That's what it is. Unit rate. Okay, there we go. Sorry. You know whenever things just come back to you at the most random times? That was my moment. This thing where it's a number over 1 is your unit rate. We are told that the total cost is $1,900 for 140 students. What this means is that if 140 kids show up, our X value is 140, it will cost a total of $1,900. Now, that is fine. That is a great starting price because what this tells me, I have an M and I have a point. I can find my B. I can find that y-intercept using what I have. I don't have to set it up into point slope form unless you absolutely want to, then by all means do so. I'm going to do it the way that I know I have taught in the past, which is this is my X and that's my Y, and the $10 is my slope. So 1,900 equals 10 times 140 plus B, and then go through the process of solving. 1,900 equals, all I do is multiply, and that's 1,400 plus B. You will need to subtract a 1,400 on both sides, not just do it on one. That will cancel, leaving B by itself, and this is 500. So for this equation, it would be y equals 10x plus 500, where that 500 is the initial price, and this 10x is the price per student, so $10 per student. So describe the number of students that must attend for the total cost at Maple Ridge to be less than the total cost at the other two venues. Right off the bat, we are underneath this Sunview. Sunview Resort started off at $600. We're already under it by $100. So that's great. Now from there, we need this equation. Y equals 10x plus 500 to be less than 12x plus 300. They do intersect eventually, but I need 10x plus 500 to be less than the second equation of that 12x plus 300. Keep in mind, I don't even have to think about Sunview because Sunview starts off at $600, and that's too much. It's over 500 already, so I don't even have to worry about that one. As long as I know it's less than Lake. Have I been calling it Lakeview this whole time? Lakeside. As long as it's less than Lakeside, I will be golden. And then just solve for X. I don't care how you solve for X. I like to keep X to my left. If you don't like to do that, that's fine too. Either way, I'm going to have to subtract a 12X on both sides. And I'm going to do a 2 for 1. I'm going to go ahead and subtract this 500 on both sides as well. Do not freak out if you get a negative number because it ends up canceling out. This is a negative 2X is less than, because that cancels too, a negative 200. Look what happens here. We're going to divide by that negative 2 on both sides. And that X value needs to be less than 100 people. So describe the number of students that must attend for the total cost to be less than that total cost. So really it needs to be, 100 kids. Once you hit those 100 kids, I actually think I did that a little backwards, but yeah, I did do that a little backwards. We're just going to make a quick little switch. Stating that once you have 100 kids, this one will be more expensive. Lakeside will be more expensive after 100 children. So as long as we have 100 or less, then I would go with the other one. And then River or Sunview. Sunview's just expensive. That $600 to start off is just expensive. That's a little excessive. All right, go ahead and get this definition as well. It says finding lines of fit and lines of best fit. Keep in mind, even though we have a line of fit definition, we rarely ever speak about a line of fit. We mainly just talk about best fit because we want the best possible relationship there is. Data do not always show an exact linear relationship. When the data is a scatter plot, yes, we're dealing with scatter plots. We're going to be dealing with messy graphs. Just take a deep breath and we'll get through it together. Show an approximately linear relationship. You can model the data with a line of fit. Once again, we don't really talk about too much of lines of fit. We talk about lines of best fit. These are the steps. This is the step for a line of fit. This is the steps for the line of best fit. Please pause the video and write the steps now because I'm going to go over them very briefly and then we're going to look at some examples. Make a scatter plot. This is the easiest part. If you know your X and Y coordinates, please practice if you don't. If you know your X and Y coordinates, you are able to create a scatter plot. Draw that line that most closely appears to follow the trend given by the data points. There should be about as many points above the line as below it. That just means it wants it evenly distributed. If there's 10 points above this line, there should be around or exactly 10 points below it as well. Choose 2 points on the line and estimate the coordinates of each point. These points do not have to be original data points. That is important for step number 3. That is going to help you tremendously for things like slope and finding your y-intercept. And then after that, write an equation of the line that passes through the 2 points from step 3. This equation is a model for the data. Now, whenever I ask you guys to create your own scatter plots and to create a line of fit and line of best fit, I have a feeling that some of y'all are not going to like the fact that you create your own lines. I mean, don't get me wrong. I like it whenever people tell me exactly what to do too, but you're going to have to get used to creating some of this stuff on your own. Now, with this couple examples, you're going to have a good little bit to kind of show you exactly what it wants, step by step, what it wants. So as long as you follow the steps, you'll be okay. So finding a line of fit. The table shows the femur lengths in centimeters and heights of several people. Femur deals with your leg, I think, your femur bone. I don't know. I've never took an anatomy class in my life. It should be does the data, not do the data. Does the data show a linear relationship? If so, write an equation of a line of fit and use it to estimate the height of a person whose femur is 35 centimeters long. Very first one, make that scatter plot. Make it. What's nice about this one is that we have a nice almost line going on. It does show a linear relationship. If it doesn't have something nice like this, say if the scatter plot truly is all over the place, that is whenever we create the line of best fit where we do our best. We can have, sometimes we just don't have linear relationships. We should hit something along those lines here in the next couple of units. But there's just some things that are not linear. This one, where it's linear, it's in a straight line. It is positive because it's going in an upward direction. This just means it's a positive relationship. We love a good positive relationship. But step one is simply making that dot or plot. So after that, you need to draw the line that most closely appears to fit the data. One possibility is shown, and it physically draws out what that possibility is. I know this. There we go. And it shows out what that possibility is. That blue line with the arrow, that just means it's going in that upward direction. Step 3 is choose 2 points on the line. For the line shown, you might want 40, 170, as well as 50 and 195. Let me tell you now, it's not always going to be this nice. You are going to have to sometimes pick your own points based on your lines. So just keep that in mind. These gave us 2 points from our table, but we might not always have something like that. And then last but not least is to write an equation of that line. Find your slope, and then use that point to find your y-intercept, which is what they do. First, find the slope. They use your slope formula. y2 minus y1 over x2 minus x1. 195 minus 170 over 50 minus 40. So it's 25 over 10, which is simplified to 2.5. I like to keep my slopes as a fraction since it's rise over run, but they apparently don't. After that, use that slope and one of the points. If you want to use point slope form, that's fine. You know by now that I like to just take my point, plug it into the slope intercept form, and then, it did not show any of that work. And then solve for b. So I would set this up as 170 equals 2.5 times 40 plus b. And then from there, I would work through the problem. So I wouldn't take the point slope form. Go figure, it doesn't show you step by step how to do that. At least the way that they do it. I don't know what happened with the slides. I don't know where those are. But just know I would do it a different way. That will give you the equation, and this is what I need you to write down. That y equals 2.5x plus 70. After going through the steps, you find that the b, your y-intercept, is a 70. And from there, you just combine it all together. Y equals 2.5x plus 70. Now, after that, the question specifically asked to estimate the height of a person whose femur is 35 centimeters long. You have to recognize that your femur length is your x. That was told to us in the graph. So all you would have to do is plug 35 in for that x value, which they do, and solve. Your person would be around 157.5 centimeters. No, don't ask me how many feet and inches that is, because without a conversion chart right in front of me, I would not know. But I think the U.S. is the only one that does everything in the metric system. So, which is fine. I like feet over centimeters anyway, but it'd be 157.5 centimeters. Line of best fit is very, very similar to line of fit. We just have best in front of it. That best models the set of data and lies as close as possible to all data points. Many technology tools have a linear regression feature that can find this line of best fit. One day, if you want to take an extreme math course, I was a sophomore when I was in Algebra 2, and I was seated in the back with a bunch of football players who cheated off me the entire time, but it's fine. I then went into college courses. So it is very possible that you could be using technology that does a lot of this for you in your next coming up classes. For this Algebra 2 course, I don't require you to get more than that TI 30, but a TI 84 may be in your future if you take higher maths. Like, I even know nursing don't quote me on it, might even need like pre-calc, I think. And I know a lot of people wanted to go to nursing or anesthesiology, things like that. I want to say that you need to take a higher mathematics. I don't think you have to go above pre-calculus, but just keep that in mind. Coaching you on calculators. All right, so it's the same steps, though. You are going to do the same exact steps for this, except you are now going to create the best line possible. So step 1, enter this is using technology. This is straight up just telling you how to use it for technology. The very first thing that you need to do is enter your data into your calculator. And then from there, it will create the equation for you. So this one, your M would be 2.6 and your B would be 64.99. So this one was kind of nice. I went ahead and rounded to where y equals 2.6x plus 65. Take in mind, technology is doing this for this example. From there, you would use that same calculator in order to create this graph, which is very similar to what was there before. And then you would find that value of 35, or when x is 35, using the calculator. What's kind of great, too, and we saw it a little bit in Desmos whenever we just looked at it, and you can even play around with Desmos. I encourage you to play around with Desmos, especially for these practice problems, and see what these points do, how to put it on the graph, how to use Desmos, especially since you can use technology. But that's how you would approach it. It's very similar to what we got before. Our values were a slightly bit different. Like, we got 2.5 for our slope and 70 rather than 2.6 and 65. But without technology, human error is perfectly fine. I'm not going to count off for simple things like that. Technology is a little OCD. So, all right. But that brings us to the self-assessment of number 4. I am going to do this, and then I want to say you have a worksheet after this. Yeah, so after number 4, you do have a worksheet. I'm going to pull up Desmos real quick and see if I can't have Desmos do most of the work. It does say use technology to find an equation of the line for the best fit. Using data, estimate the height of a female whose humerus is 40 centimeters long. Compare this height to the estimate in part A. Booger! We do have to do it. Okay, 2 seconds. So I went ahead and used Desmos, and what's kind of great is that you can go ahead and have it set up your linear regression. So let me just explain to you what I did. Over to the left, I have my X and my Y values. I was able to create a chart for you guys wanted to test out Desmos while you're on your computer. Keep in mind I'm on an iPad, so it's not going to be exactly the same as what you guys have it on the laptops. But to my left corner here, I have this table button that I was able to press and physically plug in my chart. So I've used all my X's, then I plugged in all my Y's. And then after that, it physically plotted the graph for me to create these points. Not only that, but Desmos is really cool too. You can go ahead and have your linear regression line, which is just your line of best fit. Like, don't let that linear regression freak you out. It's line of best fit. If you want to make, oh, no, I do want it to show, but I wanted a pretty color. Oh, apparently cannot. Oh, there we go. I want it like red. Let's do like Christmas theme. Oh, Patriots. Let's be nice. So, I mean, from there, you can just really play around with it. I guess, a little weird. Make them little stars. Cute little stars. So, but it gives me my equation as well. Now, with, no, I want that regression. So this one was not super duper nice. Nope. It gave me this big equation, y equals 3.0527x plus 63.53096. Keep in mind that is just your slope and your y-intercept. So if we were to scroll down here, or not. Oh, I messed up. Uh-oh. Great, thank you. There, nope. Yeah, there we go. So if I were to look down here, my y-intercept is around this 6.3 with change. Now, this would just mean for someone, now this is getting into statistics, fun fact. This just means if your humerus length, if your x value is a 0, if you have no humerus at all, the starting height for a woman would be 63 centimeters. Now, that's statistics. We're not a statistics class. I'm not going to ask you all that nonsense. But that's how you would interpret that. But that's going to be our line of best fit. That's our slope. It goes up around 3.05 every one length. One humerus length. But that's what it would look like. So, once again, you will have that opportunity to use technology while you have technology. I even recommend kind of playing around with Desmos kind of on your own. Get used to a graphing calculator, or at minimum, get used to seeing these types of graphs. I think it's really cool, but at the same time, I'm a little bit of a nerd. But yeah, so for your classwork, you will have a worksheet. Now, since the worksheet, I don't have a scanned copy of it on the iPad, I am going to let you guys work and then check your work on whenever I upload those answers. I'm really hoping that the sinus infection does not completely take me out tomorrow. Oh, goodness. Oh.
Holy cow, I am so sorry. My mom knocked on the door to let me know I had a package, and it scared the dogs. But I just wanted to end up with saying I will go ahead and post the answers whenever I get there. I'm just happy I was able to get this lesson done. I'm going to post it on YouTube right now as we speak. If you have any questions tomorrow over the worksheet, please still ask me in class or send me a message on Thrillshare, and I'll be more than happy to help you out. So, see you guys tomorrow.